All right, ladies and gentlemen, here we are. Final exam review. Semester's almost over. We had a very, never mind, I won't say it. It was interesting. And we're going to do some problems today that, I didn't write this final, but I wrote all your exams this semester. So the wording is not exactly the same as I've been going all semester. So over here, I had to add this part because I've never asked this question this semester, although I could have, I just didn't. And I don't want it to be a shock on Friday. This part C. We've done A, B, and D many times. We're going to do it again because it's a lot of points. And this kind of question shows up on two different locations. So this will be broken up a little bit for you. We can handle this one. We can handle both the questions we're going to see on Friday. Okay? So it's a combustion reaction. We're told that. So what are the two reactants for a combustion reaction? Help me out. It hasn't been that long. There's two reactants for every combustion reaction. Oh, you're having trouble because one of them is a variable and you don't know its formula? Well, tell me what its general characteristic, what it's called. The thing you burned, what is it called? We burn fossil blanks. Fuels, yes, fuel is the answer I was looking for. What is the formula of the fuel in this question? You have to be given this. C9816. My computer's doing interesting things. I will tell it to do less interesting things right now. All right, C9816. Now, this is a part I didn't tell you either. We didn't do states for combustion reaction. So, and we live in Dearborn, automotive capital of North America for some. Some people feel that way, right? When you burn a fuel, do you think your car pours the liquid into the engine and this lights a fire? This is not true. No. The fuel must be vaporized first. So I think I just told you what state the fuel is in. You have to know this on Friday. What state does your fuel start with if it's been vaporized? Gas. Vapor. Right? Okay. Gas. Now, where does your car get this oxygen from? You have to buy an oxygen tank? No. Pulls it from where? The air. What state is oxygen in the air that you're breathing right now? Gas. Thank you. So this part is not hard, right? The states, you're not tripping on me. Okay. What are the two products? Always, you have to know this, guys. The two products. Uh-oh, don't invent new formulas, please. H2O is definitely one of the products. And CO2 is the other. C being blue, O being black. So you got this far, right? You don't have your full points yet. It's not balanced. But you have to come up with this first. And guys, you don't have to write it twice like I'm doing. I'm just telling you, I got there first before I start to balance. And then how do you balance the carbon? Carbon, please. A 9 in front of CO2. Carbons are done. How about hydrogen? An 8 in front of H2O. Now you have to account for all the oxygens on the right side. So ox, 18 for 9 CO2s. 8 more for water. 26. You put a 13 here. Now you got all your points. I didn't put states. Guys, this is the stuff coming out of the tailpipe of your car. What state is the stuff coming out of the tailpipe of your car? Gas. Both of them are gases. Sorry, I forgot to put that in there, right? Hey, guys. Combustion reaction, just put a gas for everything. You just learned that right now. Piece of cake, right? All right. Now we're going to need some formula weights. Please do them right here. Why not? Formula weight. Oxygen, the word is not O. When you say oxygen in this course, have no fear of ice cold beer. Any of those 7 elements, what's the formula when they're an element? H2, have, no, nitrogen 2, fear, fluorine 2, 2 is the number. Fear of oxygen, of cold, ice, iodine, cold, not chlorine, not carbon, but chlorine, it's chlorine, CO2. The halogens, all of them are on that list, okay? All 4 of the halogens, fluorine, chlorine, bromine, iodine, are on the have no fear of ice cold beer, if that helps you remember which letters they're standing for. And yeah, so we need a formula weight. Is 2 times 16 equals 32 grams per mole. So that's for O2, which was black. And C9H16 has a formula weight. 9 times 12.01. Somebody's going to work this out for me. 16, 1.008. Some number of grams per mole. Thank you. 2.0? 2.1. There you go. Extra is good for now. And ladies and gentlemen, the only product I care about is CO2. And you're given grams. To do a percent yield, you can do grams over grams or moles over moles. You're going to need the formula weight for either of those conversions. CO2. No. It's 1 carbon, Dr. Whitaker, 2 oxygen. Don't change the formula of CO2 now. 44.01 grams per mole. Guys, that is 3 points for that work just done at the top of the screen. Get the formula weight for the 2 reactants, which will be fuel and O2. You're going to need them. Get the formula weight for CO2, because that's all Dr. Whitaker ever asks for. I could have asked about water, but who cares about water, right? We're not concerned about global warming caused by water coming out of your tailpipes in your car. It's CO2, isn't it? Okay, so you got to go to moles. I got to go to moles of CO2 for each reactant. So starting with, let's see, 5.432 grams of cyclononine. So we're talking about C9H16. You've got 5.432. Guys, it's 1 mole for 124.21 grams. Don't stop. Stoichiometry. I've got moles of one of the substances, right? As soon as you have moles of a substance, you should be thinking stoichiometry to go to moles of the desired substance, mole CO2. So there's 9 moles CO2 made for every 1 mole C9H16 reacted. And that's going to give, somebody's going to give me an answer. And it looks like I can move these 2 gentlemen over a little bit. Took up less room than I thought. So hook me up. So 5 times 9 is 45, less than half, so 0.4 something. Just throwing that out there. 0.4. See, I tricked her. The power of suggestion, too strong. 935. That could be the limiting reactant, C9H16. It might not be. We got to do the work, right? O2 is the other one. I hope you have an idea that this is the fundamental skill we've been getting at all semester. How many times have we done this now? No, don't say that. Just enough to get you ready, right? That's it. O2. And then we have, what do we have? O2, 0.4321. And 1 mole of O2 for every 32.00 grams. 9 moles CO2 for every 1 mole. No, not 1 mole. 13 mole. 13. We're talking O2 now. So 0.432 9 over 13 is going to be 0.3-ish over 0.32. This is more like 0.1-ish. We have a limiting reactant. It's a 0.1-ish, isn't it? But I'm guessing. So I need a little better than 0.1-ish because this will be the theoretical yield. My logic is 0.43 times 9 over 13 is closer to 0.3. 0.3 over 32 is close to 0.03. Oh man, 0.01. This was ridiculously low. Not 0.1, 0.01. What do we have for real? Or I'll pause. Okay. Oh, 9? That's good. Okay, that is the theoretical yield. Was there a rounding up after the 2 or no? Okay. There's your theoretical yield, and that makes this the. Does that arrow ever work for anybody? I had to do the work on the right before I figured out that this was the limiting reactant, right? That's what I'm trying to say without using words. Yeah. Oh, because I made a mistake. She asked the best question of the day. I didn't read my question properly. And that's what, and now I understand why she didn't have the answer right away, because she was probably at her desk doing the right answer, and then I had on the screen the wrong word. Yep. So kudos to this young lady. Yeah, I used this. That's not how much O2 I did of anything. Wow. Yeah, that's just awful, right? Yeah, that's just 2.345, please. 2.345. 2.345. It might not change our theoretical yield, which molecule, but it definitely changes the number.
0.05.
Good news. And sorry about that, everybody. Still, that's our theoretical yield. It's smaller than the 0.3935915. And still O2 is the limiting reactant. We're okay. And we corrected a mistake before we went too far. This new thing, here's the deal. So the most product you can make is right there, correct? We have to figure out how much of our C9H16 we used to get there, to get that amount. So here's what you do. You take this and you do stoichiometry again. You say, when I make, this is part C, when you make 0.050733 mole CO2, you used up how much of the C9H16? How much C9H16 did you use when you're using one of those to make 9 of those? How many moles of excess reactant will be left? So this is just the beginning of our answer. This is how much of our excess reactant was required to make this much CO2. What's left over from the original is how much excess there was. Sorry. And what do you got for an answer here?
0.005637.
And that is mole C9H16 used. Mole C9H16 used. And we need how many moles of C9H16 there were. So, sadly, I need just this part. So, you could take the 0.3935915 and divide by 9 to get this part. Or you can do the math here over again. There's just less typing to take this and divide by 9. Or just do the math for me right now and give me how much C9H16 we had in moles. Because that's what this is. C9H16 moles equal. This is how much you started with. And whatever's in that box, please give me the answer. 1 over 20, I think. 1 over 25. No, I'm not going to do it. 5.432 divided by 124.21, please. So that's how much you started with. And you earlier, right above this, figured out how much you used. How much is left over? So that number's still in your calculator, right? Subtract the red. Oops, sorry. 0.03. Excess. And 4 Sig Figs should do us, because I think all those were 4 Sig Figs. I think Mr. Irish likes 3 Sig Figs more than I like 4. I like 4 a lot. He likes 3 a lot. I'm just saying. If you don't want to stress out too much about Sig Figs and just go with 3, unless there's a question on the test that says how many Sig Figs are in here, and you're saying, Dr. Whitaker said Irish is always using 3, I'm going to go with 3. No, that's a Sig Fig question, everybody. If he's asking a Sig Fig question, you give the Sig Figs. So what do we got? I subtract. Oh, that is the answer. Geez. 4 Sig Figs though. 3 for Irish, 4 for me, and right now it's me. So where is the 4th Sig Fig? Which number is the 4th Sig Fig currently on the screen? 9. 3809 stays 9 or goes to 10? Does 09 stay 09 or does it go up to 10? Goes up to 10 mole excess. So that's how much of your fuel is in excess. That's the new question. You never did that question all semester. It's Mr. Irish's, he likes that question. It's a good question. It is a good question. How much junk am I going to have left over? It's good to know.
I mean, it's like it's just 4 3 points.
Yeah, it is the same. I'm glad he's seeing it's really just the same thing we've been doing all semester. Yeah, exactly. And I'm asking a different thing. And then D, D's a little bit of work. You've got to convert either this grams to moles, okay, or your theoretical yield to grams. You want to do that one? Let's do theoretical yield to grams first. D. And he doesn't give any steps, people. There will be no steps listed. Okay? So you've got to go theoretical yield mole to gram. So I've got 0.05, 07, 33, that's 2 3s. That's moles, dude. Mole times 44.01 grams per mole. Where'd I get that from? That was early, wasn't it? Formula weight of CO2. And somebody's going to have that for me. And that's gonna be, did I copy? Double six, thought I heard something. And that's gonna now be grams. And how much grams CO2 is actually produced? 0.4321, good. Percent yield. 0.4321 grams. Over it's a pretty lousy yield. Better get your engine fixed. Don't forget times 100. Under a quarter.
19.3.
And there you have it. So yeah, good one.